Hello, everyone. Good morning, good afternoon, good evening. Welcome to our webinar, IoT Observability, Enabling Real-Time MQTT Message Tracking Across an IoT Environment. Thank you for taking time to join us today. I'm Jayashree Hegde, helping with moderating this webinar. Allow me to introduce you all to the speakers for today. Gaurav Suman, Director of Product Marketing at HiveMQ, and Ryan Bateman, who is Product Manager for the Tools and Extensions here at HiveMQ. Welcome, Gaurav. Welcome, Ryan. Joined by Gaurav and Ryan is David from Tools and Extensions team, who will be presenting a live demo later. Welcome, David. Before we kick off this session, I would like to share that we are recording this webinar, and we will share the recording as well as the slides in a follow-up email. Feel free to submit your questions in the Q&A box in the control panel. Also, we'll be running 2 polls. I request you all to cast your votes and participate. Now, without further ado, I will hand it over to Gaurav. Welcome, everyone.
Excellent. Thank you, Jayashree. Hi, everybody. Thank you for joining us today. The topic is IoT observability, and the focus we have is on tracking messages across an IoT environment. So we look at some of the basics. Ryan from our product team is here, of course, to help us with the specifics of a new feature we are bringing to market called distributed tracing, and David is going to show us a fantastic demo. So can't wait. I'm excited for running this, and I'm excited for you to be here and learn more about IoT observability. So again, my name is Gaurav. I'm based out of Ottawa, Canada. I lead a function called product marketing for HiveMQ. Ryan, do you want to say a quick word, and then we'll keep moving?
Sure. So my name is Ryan Bateman. I'm the senior product manager for the tools and extensions team. I help our team build things like our Kafka extension, enterprise security extension, and I'm based out of Berlin in Germany.
Awesome. Thank you, Ryan. So before we begin, a quick couple of words about us. So we are HiveMQ. We have been in business for a little over 10 years now, and we are headquartered in Landshut in Bavaria, Germany. And what we do is we help move data to and from connected devices in efficient, fast, and reliable manner. Our services are deployed in production for more than 130 customers across different verticals, across different industries. And our platform is used really to help customers build new digital experiences, improving customer experience, and creating more cost-efficient operations. The industries we operate in, the customers we support are again in multiple verticals: connected cars and mobility, manufacturing, transportation, logistics, and connected assets and products. I just wanted to say that we are, HiveMQ is deeply engaged in the IoT community. We have various projects and industry initiatives, including participation in industry and specification standards. So that's about us. And before we talk specifically about IoT observability, Jayashree has a quick poll for all of you who are here today. So Jayashree, you can put your poll up now. So it will be very helpful for us to get a sense of where you are in terms of IoT observability, where you are today. Is there an application performance management / monitoring, right? The term might vary between vendors. If you are using an APM vendor, if you're not, I mean, do you plan to use one? In case it doesn't apply, please pick that option, and it'll help for us to know if you are using distributed tracing in your environment.
I'll end the poll now. Thanks, everyone, for participating.
Thank you, Jayashree. So observability for IoT, right? Observability, the definition really is the ability to be able to measure the state of a system. And in case of IoT, what's happening is very interesting. You are really touching systems which are way out there in the field. It's somebody who's struggling to get into their rental car because their mobile application is not unlocking the door. You have your friend waiting for their pizza, but the smart lock door, the smart lock won't open, and you end up finding yourself in a position where nobody knows what really went wrong. But ultimately, there are customer experiences and users who are getting impacted. And that happens because I should say rather, these are the kind of issues which should be expected to only grow and get bigger. Sorry, Jayashree, can you confirm if the screen is refreshing? I'm seeing?
No, Gaurav. I think there is the panel that's coming in between. Maybe you could move.
Okay, let me try that.
Yeah.
All right, sorry about that. Yeah, so what I was saying was that the couple of experiences I mentioned, that's just an example of the billions of endpoints which are out there and perhaps are always consistently exposed to these kind of issues, right? And if you look at this chart here, and it's coming from IoT Analytics, they did this assessment and projection earlier this year. So by end of 2025, we will be at 27 billion connected devices. And that's a huge number. Now, you may have seen a little different number, which was trending more towards about 30 billion until earlier in this year. But with the chip shortage and the supply chain disruptions we've had, they've redone this and they're saying 27 billion is the number. But that's a huge number. And that's a huge number for endpoints which are out there impacting users, impacting businesses. And that's why it's important for us to zoom into IoT observability today and understand exactly what's there that we can do to do a good job with this. Now, IoT observability challenges are unique, primarily because these are systems which are deployed at massive scale. There's endpoints which are driven or powered by batteries. They're out in the field. There's various components in there. Many of those act like black boxes. You don't know what's the nature and behavior of those components. The connectivity is not always stable, and contrast that with a typical IT system where the connectivity is stable. You're operating in a governed, predictable environment. And also, as you try and observe IoT systems, if you want to use conventional tooling, there's too much data. And these are the reasons which need to be sort of accounted for as you think about building an IoT observability solution for your application. Now, this tweet, and it has aged quite nicely, it's from 2015, but still continues to be the case. And really, in the case of IoT with the distributed systems, with the kind of hierarchy and the spread of application infrastructure that we're talking about, it is like a murder mystery. If things go wrong and you need to find exactly what went wrong where in a distributed environment, this is the situation we find ourselves in, which is an outage can become more like solving a murder mystery. Now, why are we getting so particular about building an observable system, right? Yes, of course, there are some basic elements which are available and have been available out of the box, and we'll look at a couple of those. But to continue to be consistent and value the observability of a system is crucial, because that's what will help you enhance your customer experience. You'll be able to find your issues and resolve them faster. That's also going to give you opportunities to make your IoT applications more productive, more resilient. And also, the reality is that the significant investments that your business is making in deploying APM tools, there's a lot of value there you can't really unlock if your underlying infrastructure is not able to give it the right kind of input, right? So by the virtue of building an observable system, you are finding opportunities to do things better, resolve issues faster, and also there's some latent value in your existing investments in, say, the APM tools that you can further unlock. So that said, let's just take a look at a big picture view of an observable system. And I'm sure many of you here have heard about these three pillars of an observable system. The three pillars typically are metrics, logs, and tracing. And we'll focus mostly on tracing today, because the topic of the webinar, as you saw, is about seeing MQTT data in motion as it moves across a system. As you trace that journey, what can we do to do that better so that we can create the impact on the customer experience side, time to resolution side, and things like that. Metrics and logs are local, on a system, on a component data that can be then correlated with what's happening on the tracing side. And that's what gives you a holistic view on your system. And that's the kind of observability that can be used then to support your business goals. Tracing is, again, like I said, is the topic of our conversation or primary focus of our conversation today. Within tracing, there is trace recording capability, which HiveMQ also offers on its brokers. And the distinction here between trace recordings and distributed tracing is pretty interesting, and we'll see that in action in a little bit here also. I mean, trace recordings is post fact for most part, right? And I was talking to David about this as we were preparing for this conversation. One of the distinctions that he made for me, which is fantastic, is that trace recordings, you can imagine this to be more suitable for testing or staging systems where you're trying things out. You're trying to see if you're recreating some issues, what does that look like? And distributed tracing, when we see it in action, you'll realize it's more about an always on system. Just like metrics are always on, systems are always consistently capturing metrics, ditto with logs. But in case of trace recordings, you are doing things more of post facto. You're trying to recreate issues, and distributed tracing changes all that with an always on model. So we'll take a look at that in a little bit here. So that's all I had to say. Ryan, I'm going to pass it on to you, and we can dive deeper into distributed tracing and the magic that it does. Thank you.
Great, thanks, Gaurav. I will just start sharing my screen. Okay, can everyone see that? Gaurav, can you see that? Great. Yeah, so I'll talk through what distributed tracing is as a whole and kind of try and set some context using an analogy, and then we'll dive into, as Gaurav mentioned, to David's demo in more detail. So what is distributed tracing? Distributed tracing is a way to trace individual events as they move through multiple really complex architectures, very large systems that you would have for these kind of IoT setups. Its main value is that you can start to get a high-level overview of an individual request's journey without needing to dive into individual systems to get too deep into the weeds too early. And this is really important because in that sort of case that Gaurav mentioned there of this kind of connected car, if you're starting to see like a latency issue, you don't really know where to start. You don't really know how to dive into this murder mystery. But we'll start with an analogy to kind of dive into this. If you're old enough to remember how sending a parcel used to work, which is that you will send a parcel and then it would kind of disappear into the ether, and the person receiving it would hope it would arrive soon, but wouldn't really have any insight into where it was or maybe what events were happening. Whereas now with parcel tracking, we have a lot more insight. So when you are sending a package, you would typically create a shipment label, which would have a tracking ID. And in doing so, you would register your package with your postal delivery service, so DHL or DPD or whoever it might be. And as that package then moves through the system, so a delivery person picks it up, this unique tracking ID is then kind of used as a way to consistently update and start to create via this service something called a waybill, which is a list of where you can see where the package has been, and you as the end customer can see, for example, when something goes wrong. So individual events might happen, but you and the kind of centralized postage service can see all this. And the nice thing about this system is it's sort of quite generic, so it can happen both with kind of you as the creator, the delivery person, or as it passes through, say, a warehouse with an automated system, or onto an international flight. As long as this tracking ID and the centralized location in which you updated are consistent, this waybill is going to be consistent. And the waybill is really where you kind of unlock the value of this system. You can start to see how long something has taken, maybe which events have happened if there's been an issue with it. You as the customer find this incredibly valuable, but the package service also finds this incredibly valuable to understand where within their system there might be an issue. And so distributed tracing is very similar to this kind of parcel tracking, where you would have a individual tracking report that you would see, have what we call a trace, where you have this unique tracking ID for your package. You have a trace ID for a request, where you would have a stopover, such as a warehouse. You might have a span. The name of the stopover would be the span ID, and the shipment label we discussed creating, that would be the trace context. So let's dive into that connected car use case and have a look at kind of an imagined architecture we've created here and walk through one of these requests. So you can see the architecture has a web server, our HiveMQ broker, a Kafka system, and then a backend, which is everything you need in this kind of full thing to unlock your rental car. Our distributed tracing system uses OpenTelemetry, which is an open standard for this kind of distributed tracing. And then it's typically connected to an APM tool or an APM vendor. In this case, we're showing just two here, Grafana Tempo and Honeycomb. But anything that is OpenTelemetry could be used to create that virtual waybill, which David will talk us through in the demo. But let's dive straight into the case. So the journey would start with you tapping open your car door in your app. And this would then create an HTTP request, which would hit a backend web server, which would start to create this trace ID and this trace context. And in doing so, would register with the OpenTelemetry collector. So that's the centralized place which is tracking this event. And then sending that to your APM vendor or tool. And as this travels through the system and new events happen, these are then registered with the OpenTelemetry collector and sent to your APM vendor. So individual events, such as here, you can see the web server is created in MQTT publish for a given MQTT topic and said this has been created with this trace ID. And this is where we start to dive into what's going to be in our new 4.9 update, which is we have instrumented our broker as well as our Kafka extension. What that means is we're now able to handle these trace contexts, register these trace IDs, and individual events like MQTT publishes. We've instrumented our Kafka extension because it's a really quite complex part of any kind of system architecture. We have mappings from MQTT topics to Kafka topics that could be many to many. They could be dynamic, for example. They could, have some quite complex variables in there. So being able to trace through that kind of complexity is incredibly valuable if you have this kind of architecture. And so the journey would end then, let's say, as it hits the back end and you start to trigger this opening. And you'd say, I've received this message with this Kafka record topic Y. And the end result would be the creation of a waybill, or in this case, the ability to dive into what this journey would look like using a tool like Grafana Tempo or Honeycomb. And here is an example of this kind of journey shown in Honeycomb. And you can see through this view, we've now sort of dived into something very similar to that package tracking. We can see all the points and services that this individual request has touched on. So you can see the service names of the web application, the broker itself, the backend, and so on. You can see individual events within this journey, such as the publish send from our web application to our broker, and then individual events within our broker, such as the publish inbound interceptor here, where it's got a 3.851 millisecond latency. And that would give you some insight immediately into, what's taking time in this journey, maybe where you might have some bottlenecks, and so on. And you can start to really kind of unlock some pretty incredible insights. Yeah, and that's kind of what's involved in kind of instrumenting this whole system. We have chosen to use OpenTelemetry because it is an open standard. It is something that we as a company quite firmly believe in. That means that you can use any APM vendor, you can migrate, and we think there's real value in that. So you can really kind of unlock, as Gaurav said, the existing investments in APM vendors. Yeah, and with that, I'm going to hand over to David for a live demo. David.
Yeah, hello. I'm one of the software engineers working on our tracing topic. So let me quickly show you what I've set up for our demo session. It is basically the same use case we already saw in the demonstration. So you have your smartphone and you want to unlock a car. And yeah, how many microservices or how many people do you need to unlock a car? It's a full data center, right? So you have the web application, the HiveMQ broker, the backend application, Kafka broker, a database. This is what we already saw on the slides, right? But also even in our HiveMQ broker, we have multiple extensions like the Kafka extension. You might have a custom extension running. You can even customize the Kafka extension. So we have mixed software components, some from HiveMQ, the yellow ones, and the green ones coming from yourself. Then we have our observability stack. So what you might already have is Prometheus extension, Prometheus and Grafana to see the metrics. And what we have new now is our distributed tracing extension. And then there is a bit tooling around that, of course, to utilize the tracing data. So here's the OpenTelemetry collector Ryan already mentioned. That's a very, very nice tool, probably worth an own webinar. We won't dive too much into this today. It is just an endpoint in your data center, basically for all your trace data, and it can transform the data and refine it a little bit, but we use it basically to forward it to an open source stack, namely Grafana Tempo. This is a storage for trace data, and we utilize Grafana to query it. But you can, even in parallel, send the data to an APM vendor, be it in as a SaaS service or also on-prem, right? So basically, with this setup, we can support any kind of observability stack, which is possible. So yeah, without further ado, let's have a look how this looks like when we get a request from the smartphone to do something in your backend and with your car. So first, just very quickly, these are the metrics with Grafana. We have some new metrics for our tracing component, so you can also monitor the health of your tracing extension, basically, like how many spans have been created, did I drop any spans, could I export all the spans to my tracing backend. So this is just, of course, to ensure that the tracing component is working fine during production. So just some new metrics for that. So I've built a very, very basic dashboard in Grafana to query this Grafana Tempo component, which stored all of our trace data. Of course, it would be boring if I would just show you something where everything went fine. We have some troubles with our application. So I prepared some queries here for high latency. So basically, I set a threshold in here, show me all traces which took longer than 2.5 seconds. Right, this is my artificial latency goal I have. If it takes longer than 2.5 seconds, my customers are not happy when the car opens. So we can have a look here. Oh no, where are my traces? No, it doesn't matter. I have examples for everything. Then we have error cases and unauthorized traces. Those are just different queries. So for example, if my web server in the front throws 500s, that's your worst case, right? Your first component throws the very, very famous 500 error, and you have like 10 different microservices behind that web server. And where do I start to look into? It's probably not the web server, right? Normally it's something downstream. So let's first look into a healthy trace. So this is the representation of this trace in Grafana. So what we can see here, it's just in the overview, that the whole trace took 62.5 milliseconds. So this is what I define healthy, right? And we see that we received an HTTP call. I hope it's big enough. Let me zoom in a little bit here when we dive into the details. So we have an HTTP call here, and our web application then talked over MQTT with our broker. It went through the broker, then over to Kafka, backend application, back to the broker, and then here to the web application in the end. Let's dive into some of these, into the trace a little bit. What you can see is how much latency did each of these components provide to the total latency. that is one of the biggest informations you want to get, like, where are my performance bottlenecks? Which application is providing the latency in my processing, my data processing. We can have a look at this span here. This is the publish receive. So this is the span we will create in the HiveMQ broker when we receive a publish packet. And
David, hi.
Yes?
Sorry to interrupt you. Can you zoom in a little more?
Yeah, the problem is, of course, I hope the UI of Grafana will forgive me to zoom in. I hope it's better now.
Thank you.
So when you open this, and this, of course, how you get to this detailed data depends, of course, on the analyzing tool you basically use. So here you can click on here, and then you see basically all the metadata which we store for an incoming MQTT publish packet. So the message destination, this is the topic, for example. You see your client ID. You see a response topic was set, which MQTT version was spoken. You see the IP address of your client. All this information you need, the quality of service level. So basically all metadata beside the payload itself, which you have on a publish message, is being recorded and tracked by us. And you can use that to create filters or to debug your traces, which you see. And then this continues here. And yeah, next thing, we add spans for each interceptor. And here it comes into play what I said. You have a custom extension, for example, which provides a publish inbound interceptor. That's one of our SDKs we have for our HiveMQ broker, right? So you can write customizations, extensions by yourself to the HiveMQ broker. And you can see that this has been executed here for 3 milliseconds. And in the details, we provide you with the information what the idea and the version of that extension was. So if there is ever a problem with that inbound interceptor, you can directly know which team, for example, was responsible for that interceptor and which version was executed, right? Maybe you didn't update one of your brokers with your extension and it's running an old version or something like this. The same for publish authorizers. And then yeah, I'm a bit sorry, this is a struggle of zooming in here. Maybe I can move this here. So then we can see here when it goes over to Kafka, in this case, to our Kafka extension, we have a Kafka transformer, which is also custom code, right? And here you can see the class name of your Kafka transformer. So this is all the debug information, or the information you will need to dive into the correct system when any of these components show you an error. And then, of course, this is a span from the Kafka extension. So here we say, oh, we send now to the Kafka topic web inbound. So you see the transformation happened, right? In the we had the topic car inbound here in MQTT, and there was the transformer basically changed here the topic to web inbound. So you get the according meta information no matter what actually which kind of processing happened in our broker here. Okay, so now we come to the error cases, or the issues you might have. So this is an example of a high latency trace. You see, before we were at 60 milliseconds. Now we have 3 seconds here. This is actually violating our latency SLO, right? We wanted to say 2.5 seconds, basically. And we can directly see which one was the contributor, right? So basically all the spans here are long because this one here blocked everything. After that, it's in the milliseconds or microseconds even. So our publish inbound interceptor was the faulty component in this case. And what I already showed you, you can directly see, oh, this is the extension ID. So if you have multiple extensions, you exactly know where to look at and in which version, and then you can address the problem very quickly with the correct team. And in this case, you probably don't need to open. There's nothing. You can assign the support ticket basically correctly to the correct team. Another case which we have is, for example, a custom. No, sorry. This is what you can see here. Sorry, is basically that the processing stopped here after the published inbound interceptor, and you can even see that an error happened. This is the error icon here from Grafana. So let's dive into this one. So error true. Okay. What happened here? An uncaught exception was thrown from extensions. Okay. And we can even dive more into this. We record the whole error information, including the exception and the stack trace, which caused the issue. So what we can really see here is everything you need to debug the issue in your production code if it's happening in your custom interceptor, right? You don't even need to go to the log file of the broker in this case, because the stack trace is right here. And you can give this directly, if you're DevOps, you can directly give this to the developers of your custom inbound interceptor and can say, this happened in production, fix this, please. So, and yeah, the last case I can show you is just basically this could be a normal operation. Your publish authorizer just said, oh, I won't authorize this request, right? Again, you get basically all the information. You can look this up. What was basically the input data? And then, of course, you have to know what your publish authorizer did and which lead to the not authorized. But you always have all the needed metadata to dive into these dive into these issues. And yeah, you see, basically there are custom events on all the spans which give you all the metadata what happened. So pub contained an error code, all these kind of things. Basically things which you always also find in the logs, where when it's appropriate, we add short events to the spans to show basically if there is something out of the ordinary. Yeah, and just for completeness, this would be, for example, how the same traces or the same data would be represented in Honeycomb, which is one of the APM vendors. Yeah, this is just a different kind of dashboard, which will basically see in every kind of APM vendor. So you can see your requests over time. You can see a heat map over time, where you can directly see basically that in this phase you had like a 5 seconds. So this is milliseconds. So 5,000 here is 5 seconds. Here you had a phase where we had traces with a latency of 5 seconds, and here around 3 seconds. So this, for example, was the high latency case I showed you with the published inbound interceptor. And then you can directly dive in. It will just look a bit differently here in Honeycomb, but you can see exactly the same information. Basically, we can quickly dive into that to see a trace. You can just drill down. And as I said, this of course depends on which APM tool or analysis tool you use for your trace data. But you can see you get the same data, you get the same trace data. You can also dive into the same information here. So I can filter to the client ID here and all the kind of things. So yeah, that's basically our demonstration.
Excellent, David. There's a bunch of questions, by the way. So let's go through these. And yeah, this is one which we knew that, you know, people who are keen observers of what was going on will like to know more about. So there's a question from Roberto around essentially the tooling or instrumenting the client. So they're asking if the firmware within the device can also be observable, or is the scope limited on the server side? Ryan, do you want to take that?
Sure, I can start, and then David can correct me as we go. So you could fully instrument whatever your MQTT client is. It would obviously need to be using the correct collector, and that is really down to whatever your MQTT client is. We have not yet instrumented our own MQTT client. We're very aware, a lot of unlocked value in that. It is on our roadmap, and that's probably where I'll leave that. David, did you want to add anything?
Yeah, so as Ryan said, we are aware of that. We have so there are two things. We have tracing of MQTT in backend applications. That is fairly easy because you are in your data center, you have your endpoints for tracing data. Your application is maybe already instrumented, maybe by OpenTelemetry or a proprietary tracing tool. And we have a concept how to enable this tracing of our own MQTT client for OpenTelemetry and probably also other APM vendors. So you won't be forced, if everything works out on our end, to switch all your backend applications to OpenTelemetry if that is not suitable for you. So yeah, just subscribe with us. You will be informed when we have that production ready. That is, we are very excited to work on that. The other story is IoT devices themselves. Right, that will be technically much more difficult because what is the problem with IoT devices? They don't have a reliable network connection. You have a limited network connection, and sending trace data from an IoT device to any kind of tracing backend is a challenge on its own. It's quite a lot of data for an IoT device. For IoT devices, you can have an embedded device. The amount of code even you need to do tracing and the memory you need for tracing could be challenging. So yeah, that's a whole other topic, tracing of IoT devices themselves. We have some, again, we have some concepts and some ideas how we could solve that in the future, but for sure, we will work on MQTT clients in a data center in the backend environment first, because that's much easier to accomplish. And yeah, just be surprised what we might come up with IoT tracing in the future, but this will probably take a bit more time.
Sounds good. Thank you, David. And the other question we have is about attaching custom. Also, they are asking, can we attach our own spans from within our customer interceptors to make the tracing or make the trace more granular? What do you think, David?
Not yet. Again, we have ideas for that. We want to collect our own experience a bit first with the whole tracing topic in production before we expose APIs basically for that to our customers. Right? We want to keep our API stable, right, and not force you to change things multiple times. That's one of our philosophies at HiveMQ. So yeah, we also want to make sure that we present something which is sustainable and works over a long time. So yeah, we have ideas, concepts, but it's not possible right now in the 4.9 release.
Sounds good, David. Thank you. And the next one here is from Hakim, and they're asking, what happens if a message is blocked at the Kafka level because the consumer is taking too long to consume? Message being blocked, is that
yeah, that's quite technical. In our Kafka extension, of course, we also use the Kafka clients to talk to a Kafka broker, and they are blocking pulling clients. That is just a thing with Kafka. So basically, if it you would just see a very long span for the Kafka receive in that case. So that's how we call that span. And what we actually track. is the whole polling time. And in that whole span, you will have an event when basically the polling is over and the processing starts. So you can see that actually the polling time and the processing time in our Kafka extension. And of course, in your backend application, when you talk to your Kafka cluster, this depends on what tracing you have in your backend application. But in the Kafka extension, we measure the poll time as well. So if there is an issue, you would see it in the trace actually.
Now, there's another interesting one here, which is, I'm assuming, more around the capabilities of the APM tool. And the question is from Ali, and they're asking that, what you were showing is granular. We are obviously following as a particular trace to troubleshoot what's going on in that specific instance. But they're asking if they have to get like a mean or an average, some high-level statistic that, okay, there were 100,000 door open attempts, and what was the average time it took? Those kind of statistics, I'm assuming an APM tool can render and do all that, right?
Exactly. I mean, this is then very APM specific. This is, of course, what we don't really want to show, because this we don't want to influence you to an APM choice right now. This is there are many factors to consider if you look for an APM vendor. But normally you get that's their business, right? To get your baseline. That's the important thing. So all the healthy traces basically define your baseline, and then they have a lot that is an typical APM tool, right? So just for the distinction, OpenTelemetry and all these, the thing which happens on us is to collect the trace data and to provide the trace data, and then the other part is to analyze the trace data. That is basically not OpenTelemetry anymore. That's not right. It's not in the specification. So there is this open source stack which I showed you with Grafana Tempo. And then I'm not sure how much actually you can do with that, to be honest. But APM vendors, their strength is to have the analysis capability, and not forget that the correlation with your infrastructure monitoring. That's one of their strengths, that they have a whole picture of your whole deployment and also have the infrastructure monitoring. So, for example, just one thing which would be crucial for the HiveMQ broker is if that your disks are in good shape, right? We persist a lot of data on disk, and that would be, for example, something which is monitored by infrastructure monitoring. And if you could have a latency issue in the broker because your disks are failing or disks are slow. So this would be a typical APM thing where you can see, and they would create an incident, for example, and they would do a root cause analysis. That's the strength of an APM tool. And we could say, okay, my web server shows, no, we have high latency, and the root cause is, oh, at the same time, the disk failed on this broker node. So the correlation stuff. So yeah, that's surely why you should have a look which APM vendor has the best fit for you to do this kind of analysis.
And another interesting element here, David, as you pointed out also, is that OpenTelemetry is that framework which is helping us define how are we going to present that data to be analyzed. So the APM tool you choose today and the one you might want to choose tomorrow, you have more choices now, because all you need to check for is OpenTelemetry compliance, right? So the flexibility you have with who you use on the APM side, if you don't like, or rather the particular example you had there around averages and things like that, if that's something which particular vendor is not offering, you can switch on to somebody else tomorrow. Nothing under there has to change, because we are already OpenTelemetry. We are already sort of working with the OpenTelemetry specification. And the same goes for what lies below the OpenTelemetry specification also, right? If your MQTT layer is not how you like it, you can bring somebody else in. So that flexibility, that's one of our principles, right? We want to keep that choice with our customers, and whether it's on the APM or the underlying MQTT layer, that's always possible. Jayashri, I know we have another poll to run, but since we are looking at some technical questions here, there's one more from Uday, and Uday's question is, can you help detail where the trace ID is created and how is it propagated through the MQTT protocol? Where it's created and how is it propagated? David, can you help?
Yeah, so basically the first application in your processing chain which has tracing support. In my demo case, this was the web application. It could already be the smartphone application, right? This really depends on how you use distributed tracing. So the first one in the processing pipeline, basically, that creates the initial trace context with the trace ID. And the propagation is quite well defined for HTTP and other protocols. So for HTTP, the HTTP headers are, for example, used to transport that information. And the format is defined. There are different formats to basically how your shipping label looks like how to format the trace data as a header. For MQTT, we will be using the user properties as a transport for the trace context. Yeah, as we already said, built-in out-of-the-box support for our own MQTT client is on the roadmap. That is, of course, the dream solution. Then you just don't have to do anything. But if you want to play with this right now, it is very, very easy actually to facilitate that. We are using open standards from which are supported by OpenTelemetry for the trace context, W3C, Jaeger-Zipkin. If you are familiar with tracing, you might have heard those names. So that's very well defined. In my own tracing demo, I did it because, as said, we don't have support yet. It's like, don't know, in OpenTelemetry 10 lines of code or so to actually add the tracing context to an MQTT publish. So as said, technically just added to the user properties.
Awesome.
Yeah.
Thank you, David. So before there's a couple of very interesting questions, but Jayashree, can we put up the poll and just get our attendees here to answer that poll, and then we'll go back to the questions we have.
I'll launch the second poll. While we continue to have the Q&A, you all can participate. Thank you.
Awesome. So the other question we have here is OpenTelemetry, right? What's special about OpenTelemetry based distributed tracing versus any other way that this could have been achieved? You know, was OpenTelemetry, the only thing keeping tracing from doing what it does now? What's your take on this, David?
Yeah, as we already mentioned, open standards are the way to go for HiveMQ. And open tracing is the open standard for tracing. There were two predecessors to that, but they still float around here and there. But OpenTelemetry is basically the standard which gained and is gaining the most traction in the whole APM world. The APM world is a bit proprietary, but OpenTelemetry is basically where everyone is committed to use, and basically all APM vendors we looked at have quite good OpenTelemetry support by now. So this was, of course, our way to go. So you have the freedom to choose every kind of solution, be it open source or a proprietary APM vendor to process the trace data from HiveMQ. Yeah. That's it.
Sounds good. Thank you, David. And Ryan, I'll let you take this next one, which is, will all HiveMQ brokers support distributed tracing?
No, so it'll be for our new platform release 4.9 and then going forward. So yeah, when that releases out, we'll be supported.
That sounds good. And perhaps a call out is necessary for the Kafka extension, which is also instrumented for OpenTelemetry now. So, as perhaps some of you already know, the HiveMQ platform is the broker itself and then the extensions. And one of the extensions which we included in our, Ryan actually in his walkthrough, and then David in his demo also included the Kafka extension. So that's also instrumented, including, for the transformers and all that good stuff. So that's all the questions I have here. Well, there's one more here from Brijesh, and they're saying that is it possible to simulate some high latency or variable latency kind of scenarios to be able to then use distributed tracing? Simulation for variable latency. Is there a tool we can suggest?
Sorry, I was just browsing through the chat myself. Can you repeat the question? Sorry.
No problem. So the question is that is there a tool available to simulate such latency variation and then use distributed tracing to measure delays? So I think in a controlled environment, they want to experiment with distributed tracing.
Not out of the box. We have basically a kind of stress test tool for MQTT. It's called Swarm. You can use that, and I think we just added also support to set user properties in Swarm. So you could also simulate to add tracing headers basically to the messages you are sending with a Swarm. And yeah, so it's a tool we use also to really stress test our broker with, like, to simulate millions of clients and these things which are hard to achieve otherwise. Yeah, you can use Swarm definitely to also trigger trace data. Trigger tracing, yes.
And the last question I have is for difference between trace recordings and distributed tracing. We talked about the tracing element. So David, what are your thoughts on trace recordings versus distributed tracing?
Yeah, as we already mentioned, trace recording is a feature I think you activated over the control center on a broker node. So it's very local. You need to know the node in your cluster, and it writes on disk, and it's outputting a more human readable format. So as we mentioned, this is great for a test or staging environment when you basically want to have a human readable version of which packets are really being sent to the, like everything. I think you can really track every packet which the broker can process, subscribes, connects, disconnects, subarcs, whatever, everything. But we don't think this is not a good tool for production use. It writes to disk. That's a latency contributor. You don't want to have that in production. It will fill up the disk of your broker node very, very quickly. As we said, this is a good tool for staging, or if you have a reproducer for an issue, then you can activate it, run your scenario, and see what you basically had. But you don't really see any distributed things, right? You don't have latency measurement. You basically just, it's like a Wireshark recording in a human readable format of the MQTT protocol, basically. And we don't get all the connected information which you have with distributed tracing. And of course, distributed tracing is production ready, right? It has a low performance impact, and yeah, and it's meant to be always on, like metrics and everything. So that would be probably the main distinction. Trace recording, still a very useful tool for testing and staging, but for production, you want to have distributed tracing for sure.
Sounds good. Thank you, David. That's all the questions I see. If there's anybody else who has questions, you can put the questions in the Q&A pod. We'll give you another moment here to ask any final questions you might have. Okay, in case not, then I'll just give you a way to be in touch with us, of course. So the way to get in touch with me is on your screens now. You're also welcome to connect with Ryan Bateman on our product team. Now, some of you, of course, might still be getting started with MQTT, or trying to learn the basics. There are great resources available on our website. Our new release for the platform 4.9 goes out this week, and that's where distributed tracing will be available out of the box. So perhaps before that, it'll be good to refresh or learn about these basics. But yes, you're of course welcome to keep in touch with us. Our community forum, and just please, if you could put a link in the chat, that will be helpful. That's the place for you to go and ask any questions you might have after the fact, and then we will try our best to answer that. There is a very active community we have on the link we're going to give you now, so please feel free to go over there and put your question, and we'll be in touch. So that said, Jayashree, that's all from my side, unless you see any other questions.
No, I think we have covered
Sounds
all
good.
the questions. Yeah.
Very cool.
Right. Cool. Thanks, David, Ryan, and Gaurav for sharing your knowledge with everyone. Thanks to all the participants for tuning in today. We hope you all enjoyed the session. Like I said at the start of the session, we will share the recording in a follow-up email, which will also have the links to key resources. If you have more follow-up questions or questions around IoT observability, reach out to us. Our community forum is always open to your questions. I have added a link here in the chat. You can use that. And thanks again for joining us today. And we will see you next time. Have a great day. See you.